In the last video, I've talked about atomic number. I've talked about how it was at first just an ordering number for the elements on the periodic table. The periodic table which is created by ordering the elements mostly according to the atomic masses, but sometimes according to the properties in each column of the table. And this was the case in the 18th century, about the time when people learned more about the elements and formulated the periodic table. And then in the early 19th century, this what was just the ordering number. That means like the number one element, number two, number three, and so on. This atomic number was found to have a deeper meaning through the work by Rutherford, who discovered the atomic nucleus, Bohr, who made up a theory of the atom to explain the line spectrum of hydrogen gas, and mostly who then used Bohr's equations to predict or to calculate the spectrum or the peak intensities in the spectrum of X-rays of many different elements. Through this work, people gradually understood in the early 20th century. People gradually understood that this atomic number, the atomic number, is actually the number of some kind of particles or electric charges inside the nucleus of an atom. And so the idea was that starts to become clear that maybe, just maybe, there are some kind of particles inside the nucleus, which each of these particles carry a positive electric charge, and the number of these particles would be the atomic number. So that's the kind of idea that was growing at that time. But still, in order to confirm that, the only way to confirm that is to actually observe or discover such a particle. And that happened when Rutherford carried out an experiment, which I'm now going to describe in this video. Okay. Now, in order to understand the significance of Rutherford's experiments, when I describe it, now I want to make a slight digression and talk about something that seems to be very, very different from physics. Now, if you have read Harry Potter or watched the film, you would know that the very first book has the title of Harry Potter and the Philosopher's Stone. That is, if you have read the British version of the book. If you have read the American version, it would be Harry Potter and the Sorcerer's Stone. Now, I'll use the word Philosopher's Stone for historical reason. Now, the Philosopher's Stone, right, as if you have seen the film or read this book, you would know that the Philosopher's Stone is something that can give people long life. So give people long life. Not just long life, but very long life. But there is another purpose of the Philosopher's Stone. If you like, an idea that has been around for hundreds of years, even before the time of Isaac Newton. And Isaac Newton was very interested in it, which is that the Philosopher's Stone is supposed to be something that can change lead to gold. Now we've seen in the periodic table that if you look at the periodic table, you'll see that lead and gold are two different elements. And the usual understanding is that in chemistry is that you can't change one element into another. Right? The elements are like the simplest substance in chemistry. You can't break it down any further, and certainly you can't change one to the other. But the dream for hundreds of years has always been to try. The dream or the hope has always been to try to change lead to gold, because lead is a really, really cheap metal, and gold is a very, very expensive metal. So if you can change something very cheap to something very expensive, that would be very nice. You'll be rich. And people have been searching for ways to do that. And this pursuit, it often comes under the name of alchemy. Alchemy, something that Isaac Newton was very interested in. And it was believed that there's something called the Philosopher's Stone that can achieve this. In other words, that can change an element from one element to a completely different element. So it has been for hundreds of years. Now, and this is what, not exactly from lead to gold, but changing of the elements. All right, the change of elements, which has the name of transmutation today. When you change an element from one element to another, is what I'm going to talk about today in this video. In this video, I'm going to talk about the very first transmutation, this change of element, that has been achieved by people. And that person who achieved that was Rutherford, the same one who discovered the atomic nucleus. Okay, change of elements. Now let's see what. Let me then start by describing the experiment that he did and exactly what element he changed to what. Okay, just in case you thought it's lead to gold, that's not what he did. I'm not sure if anyone has actually changed lead to gold even today. Right? He changed something else. Now specifically, I'm just going to write down right from the start what actually he changed. It is the nuclear reaction that I described maybe 2 videos ago, where he shot alpha particles, which are actually helium nuclei, into a nitrogen gas. Okay, into a nitrogen gas, and he changed it, and he found that that something happened, and these products were observed: oxygen and proton. But to be very specific, Rutherford himself did not actually observe this, but he did observe what he concluded must have been the nuclei of hydrogen. And at that time, the word proton wasn't around yet. It was only after Rutherford did his experiment and understood that it is actually producing hydrogen nuclei that he made the name proton for the hydrogen nucleus. But what I think is that it would be really useful and helpful for this topic to actually know what it is that to actually have an idea of the experiment that Rutherford actually did. Not only because it's important, but because the way Rutherford observed and analyzed his data involves a lot of very useful and interesting physics, which would really help in our understanding of the topic and in our understanding of how experiments should be carried out. Now, just in case you're interested, the actual paper that Rutherford wrote. Okay, I'll write down the title. You can actually find it if you search on the internet. So, Ernest Rutherford, and the paper was dated 1919. Okay, the title of that was Collisions of Alpha Particles with light atoms. And this is actually part 4 of a series of papers that he published, and it has the subtitle of an anomalous effect in nitrogen. Okay, so let's have a look at what he did. Now, I'm going to sketch the device that he actually used. This is a device which I've not actually seen this device directly, but I saw it in a BBC video some time ago. Alright, I saw the device recorded in a BBC documentary on chemistry. That's also where I learned about the history of the periodic table. Now the device looks like this. It's a cylinder, a hollow cylinder with a tube. Okay, with a tube at one end. And there are two tubes here. There are two holes here, which there are two tubes going in here. That, okay, and there is I should probably have drawn it the other way around. Wait. Okay, let me draw it this way around. Let me draw it so that the tube is on this end. The tube on this end. Okay. There's still the two tubes coming in here. And down here is a kind of a a silver plate. A silver plate here. Now there is a piece of zinc sulfide here, actually very close to the silver plate, maybe just a few millimeters away. Okay, zinc sulfide. I'll explain the purpose in a moment of these. Now, and on this end is a radioactive source. So that's a radioactive source. Now this radioactive source produces alpha particles. Now this cylinder is at first evacuated, so you suck air out to make a vacuum, and then nitrogen gas is let in, so it lets in nitrogen gas. Okay. So then I guess Rutherford probably shut his window so that the room is dark, and he started his observation. So what he found was that he starts seeing little specks of light appearing here. Lots of little specks of light. And that's the purpose of the zinc sulfide. When a particle falls on the zinc sulfide screen, it produces a tiny spot of light. Okay, so lots of little lights appearing here, like a television screen. Okay, so that's what happens. We have nitrogen gas in here, alpha particles going through the nitrogen gas, and then okay, I should say what the purpose of the silver plate is. The purpose of the silver plate is to block the alpha particle. Okay, so this blocks the alpha particle, because alpha particles cannot travel through travel through a thin metal plate. It is stopped quite easily. Okay, so alpha particles cannot go through, and which is why you can see that it is surprising, because if alpha particles can't go through here, what is it that produces this spots of light that Rutherford observed? So this setup, which was actually very simple by the standard of the time, which was about 1919. It was a very simple experiment, something that Rutherford is very good at. Simple experiments, and he draws very important or useful conclusions from them. So what Rutherford then had to do was to understand this observation. What are these little spots of light? What are these little spots of light? Okay, now I should perhaps redo my little spots a little bit. Now the purpose of this tube is probably to direct the alpha particles so that by the time it comes from that end to this end, it is quite a well-defined, maybe quite a narrow beam. Okay, it doesn't actually spread out so much, because those that spread out will be blocked by this long tube. So we expect that there's quite a narrow beam of alpha particle coming through, and that whatever the little spots of light that are produced here are probably sort of somewhere around the middle. Right, so there are some spots of light around here. Okay. So in order to understand what particles these are, Rutherford did something very similar to what J.J. Thomson did when he discovered the electron. Now, if you remember J.J. Thomson's experimental setup, he had a cathode ray tube, okay, in which instead of alpha particles, there are electrons coming out. At that time, he didn't know that they are electrons. But what he did was he studied its charge to mass ratio by putting a magnet next to it. Okay, but he has a setup where he had a parallel plate of electric charges, and then he has a magnet that he can use to measure the velocity, and then with the plate he can determine the charge to mass ratio. So what Rutherford did was pretty much the same, right? He would have used a magnet to try and see what happens to this spot of light, and by carrying out a similar method that J.J. Thomson used for the electron, he found that these whatever particles are coming out and falling on this screen and creating that little spot of light, he found that those particles have the same charge as an electron. Right? Let me describe what he found. He found that the particles that are coming out through the silver plate, okay, they are positively charged. They are positive, okay. They have the same charge as the electron, which is E, okay, and they have the same mass as the hydrogen atom. Well, he can't actually measure the charge and the mass separately, so what he found was a charge to mass ratio. So he found the ratio of the E to the mass. So this is more like a ratio. So what he found was that the particles have positively charged. Okay, that shouldn't be too difficult. Just put a magnet there and see which way it bends, and use the Fleming's left-hand rule. So, but what he found was that the charge to mass ratio is the same as that of the hydrogen. So from there, he deduced that these particles must have the same mass as hydrogen. So the same mass as hydrogen, assuming that the charge is the same as that, is equal and opposite. It's the same magnitude as that of the electrons. So because of that, therefore, so this means that he has observed actually a new type of particle at that time. So no one has actually seen this kind of particles before. People have seen alpha particles, okay, but not this. So he has observed a new type of particles, and he deduced that from this information that this must actually be the nucleus of the hydrogen atom. Now, but if you read through this paper, at the time of writing of this paper, this wasn't actually explicitly stated. He didn't actually say in the paper that he thought these are nuclei of the hydrogen, and therefore these are protons. Alright, the paper mainly describes the procedure and the property, alright, of this, the result of this analysis, without actually making any guesses or claims. But later on, people understood that these protons, these particles, are actually the same as the nuclei of hydrogen atoms, simply because by setting up more experiments to actually collect these particles in a container, they found that when they add electrons to it, they actually observe hydrogen atoms, right? So meaning that by adding electrons to those particles that are coming out, it is possible to chemically detect hydrogen, or physically detect hydrogen atoms. And at that time, probably for some time after that, I think oxygen was not at first detected. It is probably detected in a later experiment. But today, when these experiments are carried out in, say, university teaching labs, both of these particles can be easily detected using modern devices called mass spectroscopy. So, but in any case, Rutherford's work was convincing enough, right? That people believe, even though he has not actually made any claim, right? Very soon after he did his experiment, the newspaper reported that Rutherford has created a new element, which is hydrogen. So basically, what Rutherford has done was that he has taken alpha particle and nitrogen gas, and he has created something completely new, which is the hydrogen, which is hydrogen gas. And in other words, Rutherford has changed the elements from nitrogen to hydrogen and oxygen as well. So he has achieved something that alchemists has for centuries tried to do, which is to change the element from one element to another. Unfortunately, he did not do it with lead and change lead to gold. But even then, it was the very first ever element change that was observed, that was done by man. Okay, but of course later on we'll see that in nature, in radioactive materials, this happens all the time. Right? As a radioactive substance decays, it just decays into different elements. And so soon after this experiment, Rutherford understood. Rutherford made up the name proton to describe these particles of the hydrogen atom. So, although it has never been actually explicitly described as such, in fact, Rutherford has discovered the proton, if I may describe it this way.